This deeply flawed mental model, this single analogy, has been destroying the experience of software development for decades, at least for me and my 2+ decades of experience as an engineer and as a manager. And you might think that I'm overstating this issue, but I actually believe that this could be the number one cause of the downstream dysfunctions that we as team members and frontline leaders experience in software development. So I do think you're going to need to turn your brains on for this one a little bit. There's a lot of nuance here that I'm going to try to do my best to explain. And I'd love for you to let me know in the comments if I missed the mark or if you have anything to add to make this a little easier to digest. So of course, this analogy that I'm talking about, it's going to be no big surprise. It is software development is like building a house. And if you cringe internally and you have this fire that lights up underneath you when you hear this, then you really need to stick around, because I think we're going to tear this analogy down to the ground. And I'm going to make an argument that it's time to ditch this altogether and start to develop a new mental model in the industry. So the home construction process, and I do know a little bit about this now as I work for a company that does construction software. So I've learned a little bit about how this works, but there's really two kind of distinct phases. One is the design, engineering, and specification phase, which is ideation, discovery. Basically, your plan, you're kind of deciding what kind of house you want, what do you want it to look like, how many bedrooms, how many floors. Then the engineering piece, what kind of load-bearing capacity do you need? What kind of materials are going to be required to make this house safe? And then what people don't really understand about construction is that design and engineering process. The output of that is a set of detailed specs. When I say detailed, I mean super detailed, down to how many nails you need, like what brand of paint you're going to use. It's like every single little detail that's spelled out. Once all that process is done, only then do they break ground. And that process is basically construction at that point, once all the specs have been agreed upon. So this process works and is very intentionally created like this for construction, because in construction, the cost of change, of getting something wrong once you've already started construction is really high. Like, oh, we didn't pour the foundation correctly, or we didn't order enough lumber, so now we have to wait. So the whole process is centered around having construction be a predictable process. The cost and the schedule are very accurately predicted because of that high cost of change and of messing something up. So when you're comparing two domains like software development or construction, it's important to understand where they fall on sort of the spectrum of complexity, because you treat them a little differently. You have different types of processes and structures depending on where it is, how complex it is. Like you wouldn't have the same types of processes for cooking from a recipe as you would trying to develop a new dish, right? There's different things that you would do for each of those, even though both involve cooking. There's two axes. On the x-axis is the how that something is done, so the actual technology that is used, and on the y-axis is the what. These are the actual requirements. So where does home building fall in the spectrum? So let's think about what we know about building a home, the technology, the how. The materials are all pretty well known, right? This is just drywall and concrete and lumber and shingles and wiring and plumbing. Like the materials themselves and even the process that is used to build and design the house, they're all pretty much well known at this point. There's still some innovation, obviously, that happens, but there's not a lot of unknowns that you're going to run into when you're building a house. And then on the what side, on the requirements, remember, building a house, we're specifying everything up front because we can. We've all been in houses before. We know what to look for in a house. We know there's bedrooms, there's a bathroom or two, there's a kitchen, there's a garage. We know what the specs are for a house. With home building, my argument is that it is in the simple domain where the technology is known and the requirements are super clear. So what are some of the aspects of something that's in the simple domain? Well, it can follow a linear, predictable path because those same steps have been followed for decades and they've produced the same results. The other thing is once it's done, it's actually just done. It's not something that's continuously evolving. Now, obviously a house, you add on to it, you paint, you remodel. But for the most part, the house, once it's built, It's done. There's not continual change and cultivation and discovery that's happening to make that house livable. It's just done. It's built. And I want to hit this point home that the cost and the time are predictable in the simple domain because you've spec'd everything out in advance. These are all of the tools and materials that you use to build a house. You have the prices for those. You have all the labor costs for those. You can stretch that out over time because you've built, your drywall people can come in and drywall a house in 2 days. Your framers can do it in 2 days. Your roofers can do it in a day. They've done this over and over again. That's repeatable. So therefore it is predictable. Okay, so now let's actually apply this mental model, this process, this way of thinking to software development. Initially there's research that happens, right? We don't even know what problems exist. So let's go conduct some research. Maybe there's actual user studies. Maybe there's some prototyping to put things out there to see what is the problem that we want to solve with the software. There's the architecture phase, which is once we have sort of an idea of what the problem is, we do some solutioning. And we actually build sort of, this is what we think we want with the user interface. This is the architecture that's going to support that, kind of, and fleshing out what that infrastructure looks like. And the specification phase, and remember, in construction, this is a very detailed set of specifications down to the paint colors and the brands of nails and everything like that. In software development, we do this with user stories, data models, designs, and then we can actually develop a plan. We do all this work up front so that when we get to coding and testing, when it gets to the software development team, that process can be super predictable. So this is the process of assembling the software per the spec. So that's how the software development version of this construction mental model works. So where does software development fit on this complexity chart here? Just like we did with home building, on the x-axis is the how, or the technology. So in software development, some of the technology is known. We can decide on the stack, but it's frequently changing. Even in the middle of a project, even as you go, you're going to need to adopt new libraries. The technology itself is constantly changing. So on the y-axis, the what, the requirements, are they more clear or more ambiguous in software development? And what we could argue is that, well, they can be made clear. We can gather all of the requirements up front and build to those. Yes, you can, but were those the right requirements? And raise your hand if you've experienced changing requirements in the middle of a software project. It happens in every single project. So we need to acknowledge the fact, rather than trying to make all the requirements clear up front, that they are going to change as we learn. We're learning new things about customer behavior. We're learning about the actual technology, and that might make things less feasible. So we need to take a different approach. People in product might have new research that's coming out that they need to make changes to something in flight. For those reasons, I think it's pretty well understood now that software development is complex. It's in the complex domain. Things in the complex domain have different characteristics than things in the simple domain. It's dynamic and exploratory in nature. The environment is changing. The technology itself is constantly changing. And then we don't always know what the solution needs to be until we put something out there and see how the environment responds to it. And then we can adapt. It's not like building a house where we've built this same house over and over again, even if it has a few more bedrooms or, a 2-car garage or a 4-car garage. It's all the same processes. It's all the same materials. It's the same contractors and things that are building these homes. So each software product is unique. Now some of them are similar, but if it wasn't unique, then you wouldn't need to be building it. You would just use something else that existed. We're going to be learning how to build this thing now. Now we have some of the same tools we used to build the last thing, and we have some learnings from that, but we don't really know what we're going to encounter because it's new. There's another major disconnect here that I'm only just now understanding how to articulate, and certainly people who aren't team members and in building software every day, they definitely don't understand this. And that is back to this idea of detailed specs. In construction, we have this dynamic, iterative process to develop these detailed specs. The detailed specs then are what get assembled during construction. Well, in software development, what is the detailed spec? What is the document that determines the system behavior? It's the code itself. And I put the tests in here as well. The code is the spec. The code isn't the assembly of the spec. It's not a process of production. It is the specification. And we should have this dynamic iterative process. And given that, really the only predictable parts of software development are once we have the spec, the code, and we do the build, then we can take those assets and we can deploy those to the target environments. Oh, and guess what? That's all automated for the most part in our industry. So we've already automated away the predictable parts. The act of coding is the act of discovery and developing the specs. So it's not a process of production or construction. So this home building construction analogy really is absurd when you think about it. What would home building actually look like if it were in the complex domain and then maybe were applicable to software development? So, like if you wanted to move your kitchen upstairs for some reason, or you've got a house that's already built but you need to swap out the foundation for some new, there's a new type of concrete. So you're going to just gut the foundation and deploy a new foundation. So you'd have to design a house to have a modular foundation that you could just swap out and put a new one in. Or if halfway through building, the world ran out of 2x4s, and now you have to come up with a new solution for wall framing even after you've already built half of the walls. Or like, let's say 4 times a year, this house is going to host a music festival and 100 people are going to be there. And so you need to be able to support that number of people flushing toilets and running the shower and all the electricity usage that's going to be going on. So, or let's say you're a home builder and you built a subdivision and you want to design a new living room and you want to apply that new living room design to all the houses that are already there. So you need a modular design. You can lift out the old living room and swap in the new living room. Or rather than being an independent house, you rely on integration with a neighborhood where I'm outsourcing my electricity to my neighbor. So I'm going to have to integrate with his electricity, and I'm integrating with the plumbing of this other house. Or imagine that as soon as a light bulb goes out, you need to be notified within 5 minutes. And within 30 seconds of being notified, you need to have that light bulb replaced. Or the permits that you've got to build the house, they change every 6 months. You need to go in and redesign stuff because it's no longer legal to even have walls built out of 2x4s anymore. So now you need to go in and swap those out. Or imagine multiple times a day, somebody is trying to break into your house. And sometimes they actually do break into your house and they steal all your stuff. And instead of you being able to file an insurance claim and get your stuff back, you actually have to go to court and you end up losing your house and becoming homeless. Or let's say you're having a house built, but you don't know if you want your master bedroom on the first floor or on the second floor. And so you decide, well, let's put it on the first floor for a while and then we'll try it out. And then a month later, we'll move it to the second floor and see how we like that. And then we'll make the final decision. So it's ridiculous, actually, when you really think about it, to use something as stupidly simple as building a house and applying all that process and stuff to something like developing software. Developing software is different. I couldn't even think of something analogous in the physical world, maybe like space exploration or something that was truly exploratory. Or maybe gardening, because there's the cultivation aspect of gardening that you have to actually continually care and feed for it. Or like maybe designing a whole city. The population of the city is constantly changing and growing, and the whole city blocks are kind of torn down and repurposed for commercial. And so over the course of decades, there's a lot of complexity there. But imagine that shrunk down into the time frame of months or even weeks. So getting to the crux of the issue here, where the people who hold the construction mental model in their head and are trying to make the process of coding and testing as predictable as possible by doing all the upfront work, then managing that coding and testing process as if it were construction. That is the crux of the issue. And unfortunately, even Agile and Scrum that and Lean even tried to combat against this, ultimately, I don't think that was successful. This is still, even in Agile contexts, still how it works. And there's lots of downstream dysfunctions that have occurred. And I'm not going to go into everything here because I have another video where I talk about the broken industry. When that process of development becomes more of like an assembly line type of a process where success is just meeting the deadline, meeting your quote commitments that you never actually made. And the cutting of quality that has to happen to meet those dates, which results in, more defects, harder to read code, it becoming more and more expensive to make change because of the accumulation of tech debt, because of the brittleness of the systems, because in an environment like this, we're not constantly caring and feeding for the system itself when we're just rushing to the next sprint, the next set of scope that was sort of predefined. And all this really kind of culminates and leads to burnout. So what can be done here? I think the main thing is education. Is us as team members and frontline leaders and things need to really hone our own mental model of software development and develop our own new language maybe, and then help educate the people who are ignorant to how it actually works. And I hesitate to say that we need a new framework because I am almost anti-framework at this point, but I do think our existing frameworks, they've failed in some ways to be discovery centric. They're still more execution centric. And I think if you ever follow Marty Kagan, who does product stuff, I think he's pretty close with his model of bringing the teams into the discovery process and having that feedback loop in place. So I do think that there's better ways out there. There's also no like good framework that elevates refactoring and elevates ethical software development and bakes it into the framework. I know XP kind of did some of that, but there might be time to pull some of this together into a new set of patterns, practices, frameworks, ethics, whatever. So I know probably in future videos, I'll brainstorm some of these ideas and see if we can get some community involvement in that. And really, I think we need leaders to step up. And I did a video on the most common sort of leadership failure modes, I think, in software development. And so if you are in leadership or you're looking to go into leadership, that might help you avoid some of those pitfalls too. So thanks for sticking around for this one. It was maybe a little tough, maybe a little too cerebral. Let me know in the comments what you think. If you have any additional feedback on this, we can iterate on this whole concept. So thanks a lot. See you later.